So today we're going to look at free fall and terminal velocity in the kinematics unit. And if you recall from before, we were talking about the study of motion kinematics, in which we were looking at the 5 key equations to describe changes in an object's motion. So before we were talking about an object that was falling in a real life situation, there's always going to be some air resistance. Sometimes air resistance can be enough to have a significant effect on the falling motion of an object. And if we consider a video here, and so now just before this person jumps out of the airplane, so we've got a parachutist here that is getting ready to jump out of the airplane. There is a downward force, which is the force due to gravity, is acting on this parachutist before she even jumps out of the plane. There is also an opposing force, and this is actually the normal force pushing up on the parachutist from the floor of the plane. So she's not falling because the floor of the plane is providing enough force to keep her where she is. But the moment she steps out of the plane, you'll notice she starts to accelerate. And you'll notice here in the corner, they have a velocity on her. And so this is in meters per second. So she is now going late into the 40s and 50s. Meters per second is the rate that she is falling. And so you'll notice that she is accelerating at a slower rate. And when the air pressure, the air resistance, which is acting upwards on her, equals the force due to gravity, the acceleration due to gravity, then what happens is she is traveling at a constant velocity, or this is the terminal velocity of 55 meters per second. So again, when we're dealing with something like this, a situation like this, then when the air resistance on the parachutist is equal to the force due to gravity acting on the parachutist will stop accelerating and stay at a constant velocity called terminal velocity. So here, the terminal velocity for this parachutist is 55 meters per second. So what we have here is a video of a bowling ball and a feather that are being dropped within a vacuum chamber. Now this is a massive vacuum chamber, and all the air has been pumped out of it. And as a result, there is no air resistance acting as these two objects are falling. And you'll notice here that the feather and the bowling ball are falling at the same rate. And according to the story of Galileo's Leaning Tower of Pisa experiment, he's said to have dropped 2 spheres of different masses from the Leaning Tower of Pisa to demonstrate that their time was independent of their masses. And Galileo, and going through this video again, demonstrated that the 2 spheres, even though they were different mass, dropped with the same acceleration, which disproved Aristotle's theory of gravity, which stated that the fall speed of objects was related or was proportional to their mass. So if we look at a typical type of problem that we might need to answer for a test or assignment, would be if a potato is shot straight up into the air at 80.0 meters per second with a potato gun, and we are told to ignore the air resistance. We, in part A, are asked to find what is a potato's maximum height. So let's highlight a couple things here. And the first thing I want to highlight is the 80 meters per second. And that's going to be, if we think about this situation, this is going to be the initial velocity of the potato. And we're also given that we need to find the maximum height of the potato. And in the second part, we're asked how long to reach maximum height. So let's look at part A first. And going back to the question, Okay, our initial velocity, because the potato is shot straight up in the air, at some point it's going to reach the maximum height. And when it reaches maximum height, it won't be moving up or down. It'll momentarily, for a split second in time, be perfectly still in midair, and then it start to fall rapidly again. So the initial velocity here, as I said before, is going to be 80.0 meters per second. And the acceleration from last day, remember that at close to the Earth's surface, it's 9.8, and it's negative because the acceleration is downward as opposed to the initial velocity, which is upward. So the initial velocity is positive 80 meters per second, and let me emphasize that, the acceleration is negative 9.8 meters per second. Now, as I said before, the final velocity is going to be 0 meters per second, because what's going to happen is it's going to stop rising and then start to fall and accelerate downwards. So what we require here in this question is the displacement. So that's the delta D. Now, we have to apply a formula, and remember last day we were looking at the 5 key equations. And so there's the 5 key equations, and we have in our in the question we've got initial velocity, final velocity, acceleration, and we're looking for the displacement. And the equation that has those 4 variables is equation 4. So it's going to be then the VF squared is equal to VI squared plus 2 times acceleration times our delta D. Now, to solve for delta D, to solve for the displacement, we are going to subtract VI squared from both sides as our first step. So we're going to subtract VI squared from the left and the right side. And when we simplify, we end up with, if I move this side over, so VI squared minus VI squared is going to be, and this is a squared, is going to be 0, plus 2a times delta D is going to be 2a delta D is equal to VF squared minus VI squared. And next, what we'll do to both sides is divide by 2 times the acceleration to solve for the displacement. So we're going to divide both sides by 2 times the acceleration. And so what that leaves us with after the acceleration cancels out is we're going to be given delta D, or the displacement, is equal to the final velocity squared minus the initial velocity squared divided by 2 times the acceleration. So now substituting in the values that we determined previously, the final velocity when the potato hits or reaches maximum height is 0 meters per second. And that is squared, and 0 times 0 is 0, minus 80.0 meters per second squared, and we divide that by 2 times negative 9.8 meters per second squared. So if we go to a calculator, and 0 squared is 0, minus 80 squared is equal to negative 6,400. Now we're going to divide that by, and in brackets we're going to put 2 times 9.8, change that to negative, close the bracket because we're dividing both by 2 and negative 9.8, and you get an answer of 327, approximately 327. And remember, if we look at our initial question, we had 80.0 meters per second as, so the number of significant digits is going to be then 3. So we can write 327 meters. Or we could write, if we wanted to write it in scientific notation, 3.27 times 10 to the 2 meters. So your therefore statement is, therefore the potato will reach a maximum height of 327 meters. So the next question, we are asked to find out how long does the potato take to reach the maximum height. So again, we have all the same information we did previously. So we have initial velocity of 80 meters per second, 80.0 meters per second, and we've got acceleration is negative, and again, I got to emphasize that that's negative 9.8 meters per second squared, and a final velocity of 0 meters per second. So this time, since we're asked to find out how long does it take, then we're actually asked what is the elapsed time, or delta t here. So this is what we were trying to determine. So we'll go back to your 5 key equations. And so in this equation, in this situation, we are not given displacement. Displacement has nothing to do with our question. And the question that involves final velocity, initial velocity, acceleration, and delta t is this one right here, which is the second equation. So you're going to substitute into that equation for initial velocity is 80, the acceleration is negative 9.8 meters per second squared, and the final velocity is 0 meters per second. And rearrange this equation for delta t and determine the elapsed time.